Hi, the purpose of this video is to help you make the connection between the graph of f, which is the graph you see right here, the blue graph, and that's the graph of actually y equals the sine of x. You should probably recognize that. And then also then the graph of f prime, and we're going to generalize this to other functions, but for right now we're working with f of x equals the sine of x, and f prime of x, which we should know to be the cosine of x, but anyway, we're going to try to generalize this, and I want you to just be looking at a couple things on this graph. Okay, number one, I want you to notice that in the upper right hand corner of your graph you see the value of the function right here highlighted up there, negative 0.909, depending on the value of x. Now when x is this value up here, you can see that as x changes, the y value changes as well. Well, that's not anything new to you. You know, as x changes from left to right, the y values usually change, unless it's a constant function. But anyway, as x moves, so does the y value. Okay, so the y value changes. But the thing I really wanted you to look at here was not only do the y values move or change, but also the slope at that point P changes. So notice that the number right over here, the slope with that little p, just kind of like a subscript there, slope at p, that's what that means, slope at p. Okay, well that's changing. Notice that when the slope, when x is kind of like right in this little area here, then the slope is positive. Notice that all these values, the slope is positive because the tangent line has a positive slope. And when you get here to the top, really hard to dial these numbers in, by the way, but when you get to the top, the slope is 0. But then just to the right of that, this is a critical concept here, just to the right of that, the slope of the tangent line then is negative. Okay? And negative all the way down until we get to that other low point. Okay, so like the bottom of the valley, the slope is 0. And then as we move from the bottom of the valley up a little bit, the slope is positive. So if we always think about our movement along the graph being from left to right, as we move from left to right, we know that the function is increasing as if the y values are getting bigger. Okay, and the function f is decreasing on the intervals in which the y values are getting smaller. Okay, and then again increasing, y values increasing, y values decreasing. But the key connection here between increasing and decreasing to the derivative is as the y values are getting bigger, you should notice here something about f prime. Okay, as the y values are getting smaller, what else do you notice about f prime? Okay, so I'm going to kind of let this slide so you can kind of see it move. But what I want you to notice is the connection between when f is increasing, there's something important and significant about the derivative. When f is decreasing, there's also some other connection. There's also something else really important about the derivative. Okay, because we're not just kind of glimpse into the future, we're not always going to be able to look at the graph of a function and be able to tell whether it's increasing or decreasing, and so we're going to need to be able to make those connections between derivative being positive and the function increasing, and derivative being negative and the function decreasing. So I kind of gave it away right there. Rewind that if you didn't catch that. But that's the connection. When f prime is positive, let me see here. So here f prime is positive, and we notice that f of x is increasing. Okay? Notice here f prime is negative. Well, guess what? F of x is decreasing. So that's the connection. Okay? Now I also want to show you some other stuff here. Show x and f prime. So if f prime is negative, notice f prime down here changing. If f prime is underneath the x-axis, it means that f prime is negative. Underneath x-axis means f is negative. Or in this case, f prime is underneath the x-axis, so therefore f prime is negative. Slope of the tangent line is negative, f prime is under the x-axis. And then over here, slope of the tangent line positive, f is above the x-axis. Okay, so that's the connection. Let's go all the way back here. F prime above the x-axis, even though it's approaching it, it's still above. then once that f prime is equal to 0, notice that we have an x-intercept for f prime. And then here, f prime is negative. Notice that f prime right down there is underneath the x-axis. F prime 0, f prime on the x-axis. Okay? F prime is on the x-axis when f prime is equal to 0. Equal to 0 means on the x-axis. Okay? F prime positive means that f prime is above the x-axis. And so we're going to graduate to two things here. I want you to make the connection that when f is increasing, f prime is positive. When f is decreasing, f prime is negative. You should write that down. The other thing I want you to make a connection with is that when f prime is negative, f prime is under the x-axis. And when f prime is positive, f prime is above the x-axis. So let's just say I asked you to graph the derivative of f of x. Let's say you didn't know that it was that the f of x was the sine of x and that f prime is cosine. Okay. Notice when that point P, or when the tangent line is horizontal, f prime hits the x-axis. Okay. And notice when f prime is negative, f prime is under the x-axis. And so if we draw the graph of f prime, we see that it follows the graph of y equals cosine of x. Well, we already knew that the derivative of the sine was the cosine. We already knew that. And there's a reason. Okay, so that's the goal here, is that you understand the connection between the graph of f and the graph of f prime, and why the graph of f prime looks the way it does. Okay, so a couple key things here again. I want to stop it right about here, and I want you to notice the connection between f prime being equal to 0, the slope of the tangent line being 0, and f prime being right there on the x-axis. We have an x-intercept for f prime. Okay, notice the next x-intercept for f prime is when we have the next horizontal tangent line on the graph of f. Okay, and then as x moves along the curve, or along the x-axis, we see our next x-intercept for f prime. So the vocabulary here, the terminology gets kind of tricky because there's a lot of letters in here. There's f prime, and there's going to be f double prime. For right now, I want you to focus on f and f prime. Okay, so f and f prime have a relationship. Okay, and so what I'm going to do here is I'm going to challenge you to draw the graph of a derivative when you see the graph of the function itself. Okay, so again, I'll just let x slide along there, and you can see the slope of the tangent line corresponds to the value of f prime. That's the third thing. The slope of the tangent line to f is equal to the value of f prime. Okay, I'll say it again. The slope of the tangent line to the graph of f is the same thing as the value of f prime. That's important. Very, very important. Okay, I'm going to pause the video and get the next screen ready, and we'll see if you can graph a derivative based on the graph of the function itself. All right, well, here you go. You've got x moving along. Now this is a different curve. Doesn't matter. Well, I mean, it does matter, but I don't want to give it away by telling you what the name of the curve is. You might be able to figure it out anyway. But nevertheless, you see as x changes, you can see the point P is following it along, just like on the last curve. What I challenge you to do is I challenge you to come up with the graph of f prime based on this graph of f. Okay, so you can see I can stop it here different points along the way so you can see y values, but as soon as it goes like that. Okay, so let me back up a little bit here, and you can see the y values are really, for f prime, is really, really big because that tangent line has a very steep slope. Okay, so the slope of the tangent line we can see is 19, a little over 19, when x is just bigger than 0. And I'll tell you this though, that the y-axis does act here in this case for this function as an asymptote. So this function never does cross the y-axis, okay? And so anyway, as x moves from left to right, you can see a little snapshot right there. The tangent line has a slope that's not as big as it was just to the right of 0, but just we move to the right of 0 a little bit towards 1, we can see the tangent line slope is getting smaller, but it's still positive, okay? So in other words, the y values on this function are increasing from left to right as x changes from 0 to, over here it's about 9 or so. But anyway, if you wanted to go ahead and give that a shot, try to graph the derivative of this function as x changes from left to right, I'm giving you different values. Notice the slope is really, really small, 0.241 of the tangent line, and then going all the way over here, and we get to the end of this particular domain. 0.115 is the slope of the tangent line of point P when x is a little bit over 8, almost all the way to 9. Okay, so anyway, give that a shot. I'm going to pause the video and try another one. Well, actually, I'm going to pause the video. I take it back. I'm not going to pause the video. I'm going to show you f prime here in a second, so I need you to pause the video yourself so you can give it a shot before I show you the answer. Okay, so here I'm going to go. I'm going to show x and f prime, and as x changes from just over 0 to just over 8, we can see the value of f prime is really high. It's even off the screen here. It comes down into view just right there, and then you can see it follows this path right here. So if you recognize the blue graph being the graph of y equals ln of x, we can see, and this is just for x greater than 0, because again we can't take the ln of negatives and we can't take the ln of 0 either, but that's why the green graph, the f prime, represents the graph of 1 over x, which is the derivative of ln of x, but also just for x values greater than 0. Okay? So f prime represents the graph of 1 over x, the derivative of f, and hopefully you're starting to make the connection here, and hopefully you were successful at drawing that derivative. We're going to give you another shot. Okay, so here is y equals f of x, and you can see that it's an exponential function, and your job is to try to figure out what the graph of the derivative is. Okay, so I'm not going to talk as much on this one. I'm just going to ask you to try to draw the graph of the derivative. Okay, and pause the video because I'm going to show that here in a second. Actually, what I'll do here is I'll show f prime as well as point P along the curve of f, and you can see as x moves from a to b, the value of the derivative is right there at the value of the function, and when I show the graph of the derivative, it's actually the same as the graph of the function itself. So, and that's how exponential functions work. Basically, the graph of the derivative is the same as the function itself. Okay. All right, so one more pause, and then we'll get to a polynomial function, which you can't just use your knowledge of derivatives. You're going to have to be able to graph the derivative based on information you're seeing on the graph of the function itself. Well, this will be your biggest challenge. I limited the domain from a to b, and x changes, as you can see, from a to b, and so your job, I should say, is to draw the graph of the derivative based on the graph of the function itself. Let's see here. All right, there we go. X is moving. Your job is to come up with the graph of the derivative, and I'm almost at my 15-minute mark, so I'm going to go ahead and show it. Pause it if you don't want to see it. There's your f prime. Show f prime. Great exercise. If you were able to graph the derivative, awesome job.